everyone, let's introduce. This one is Hermes 48 volts robot chassis. One of its features is that maximum external power consumption. It's up to 1,400 watts. It is applicable to like embodied, intelligent robotic arms. If there are high power consumption requirements for the upper module, then this is a very ideal robot chassis. Let me introduce a function of this chassis. Similar to interface, the first thing that comes into view, you can see two depth cameras. The depth camera is used to do some overhanging obstacles. You can see in the middle that there is a low LiDAR for some overhanging obstacles. For example, low slippers, and so on, can be used to avoid obstacles. In addition, look here. This plane is our LiDAR plane. LiDAR planes are mainly used for mapping, positioning, and navigation. It's the primary eyes. Then about the following parts. This is the collision sensor. For example, when the robot collides with some objects, it triggers the collision sensor. Therefore, there is a backward logic. Easily bypass this obstacle. And then what we can see is this 48 volts chassis provides two channels of 48 volts power supply. Maximum external power consumption 1,400 watts. This power consumption is actually very high in the industry. In addition, what you see is this is the LoRa module. The blue one is the LoRa module. It's dealing with multiple robots. Modules to communicate within a scene can achieve multi-machine obstacle avoidance. In addition, this motherboard is we use our YD3399 Android motherboard. It runs some of our algorithms. Also, you can see that there's a charging shrapnel here. The charging shrapnel at the back. When our robot autonomously returns to the charging pile, it will make a precise alignment of piles to achieve such a function of automatic recharge. Then the battery. There's a mechanical switch. The battery can be switched on and off manually. The three buttons you see now. The red one is the emergency stop button. If there are some emergencies during the operation of the robot, you can press it forcibly. At this time, the robot will urgently stop, prevent some unnecessary risks from occurring. Then this one is brake button. When the robot is running, its brake button is released. If you need to push manually, just press it directly. When the push is complete, click again to resume. And then there's the switch button. Long press the switch button to shut down. This battery is 44 volts, a large capacity battery of 29.4 Ah. It can provide two channels of 48 volts. A upper module power supply interface. The chassis is fully loaded. It can reach 16 hours of operation.